After completion of the illustration number 9, I would like to share the new concept with you, and that is available in the illustration number 7. In the illustration number 7, the data is available about the details of monthly sale of mobile phones and its profit in lakhs for the last 6 months for a company making mobile phones are given below. They have given first column number of mobile phones sold and other is profit. So I would like to use first one column as X and second as Y. Okay. Below the table they have given find the correlation coefficient between number of mobile phones sold and its profit. My dear friends, I mentioned here the two columns X and Y. Dear friends, in the previous example, X and Y has a big numbers. At that time I suggest that we are not comfortable with the big numbers, so we always convert the big numbers into small numbers by using method of change of origin. That is the property. Okay. So now here the numbers are small. So it's a good news. There is no need to be worried. I specially request you, there is no need to find out mean every time because it is a wastage of time according to me. Many teachers are going to suggest that first you have to find out mean, but I suggest that there is no need to find out any kind of mean. Numbers are small, so I don't want to convert X into U and Y into V. Instead of that, I would like to use the original variable because of numbers are small. So get total of this column and then product X into Y. 6 3s are 18. Here is 80. Here is 180, 50, 63 and 40. Then square it. X square. It is 9, 64, 144, 25, 49 and 25. Then Y square. 36, 100, 225, 100, 81 and 64. My dear friends, in the previous question I used the formula R is equals to n sum of uv minus sum of u into sum of v divided by first root of n sum of u square minus sum of u whole square other root of n sum of v square minus sum of v whole square. But here I don't have any information about u and v. We are using original variables x and y, so I would like to use here x, y. It is x, it is y, x, x, y. Minor changes. My dear friends, a very easy formula because of we don't have to have conversion of any kind of new variables. Instead of that, we are using the original variables. So I would like to continue. Here you have to mention the heading correlation coefficient, and it is Rxy because of we don't have to find out RUV. So R is equals to n sum of xy minus sum of x into sum of y divided by first root of n sum of x square minus sum of x whole square other root of n sum of y square minus sum of y whole square. Now I need total of all the columns. After having totals of all the columns, we have to mention our formula. R is equals to n sum of xy minus sum of x into sum of y divided by first root of n sum of x square minus sum of x whole square other root of n sum of y square minus sum of y the whole square. This is the formula. So I would like to replace the values. N, it is called number of pairs. So 1, 2, 3, 4, 5, 6. So 6. Sum of xy. So I have 431 minus sum of x. It is 40 into sum of y 58 divided by first root of n is 6 sum of x square it is 316 minus sum of x 40 its whole square other root of n is 6 sum of y square is 606 minus sum of y 58 the whole square. Now the product of these two things it is available 2586 minus the product of these two things it is 23 20 divided by, in the first root of 6 into 316, it is 1896 minus the square of 40 is 1600 into other root 6 into 606, it is 3636 minus the square of 58, it is 3364, and subtracting the difference between them, it is 266 divided by the first root difference is 296, other root difference is 272. Now the 266 divided by the multiplication of both the numbers and then take the square root, and it gives 283.75, and the answer we got it is 0.94. It is our R. So R is equals to 0.94, which is very near to 1. The interpretation is compulsory to written every time after getting our answer. So your interpretation is there. Our answer is very near to 1. That means what? There is a high degree positive correlation between the variables. So my dear friends, I discussed the three approaches with you. That the first one is you have to subtract mean from the variables. At that time I used the formula R is equal to sum of x minus x bar, y minus y bar divided by first root of sum of x minus x bar square, other root of sum of y minus y bar square. But this method has a serious limitation. This is useful only when if your means are integer values. If they comes in decimals, so it is useless, it is time consuming approach. So instead of this, I would like to always suggest, always you have to go to solve your question of correlation by shortcut method. Shortcut method means what? You have to convert your x and y into u and v. So we have a formula R is equals to n sum of uv minus sum of u into sum of v divided by first root of n sum of u square minus sum of u the whole square, other root of n sum of v square minus sum of v the whole square. And if your numbers are very small, we know that we are not comfortable with the big numbers. At that time we have to convert x into u. But if they have those small numbers, it's a good news. So directly we have to use the small numbers and the formula is changed. So R is equals to n sum of xy into sum of x into sum of y divided by first root of n sum of x square minus sum of x whole square, other root of n sum of y square minus sum of y the whole square. These are the formula given by Karl Pearson, and this method is known as product moment method. My dear friends, in your textbook many examples of such kinds. You have to get the examples and solve it by yourself. Explanation is very easy. If you can't get the idea clearly, you can call me anytime. Thank you very much.